Hello and welcome. So in this video, we're going to be talking about segment relationships in circles. There's three basic theorems that we do see pop up involving different segments with circles. So the first one is called the chord-chord product theorem. So remember that a chord of a circle is just a segment that has endpoints on the circle itself. So for example, if I give you these two chords and we call this A, B, C, D, and E. The chord-chord product theorem basically says that if I take the two parts of this segment and multiply them together, it would be equal to the two parts of this segment multiplied together. So here we can say that AB times EB is equal to CE times ED. That's the theorem in a nutshell. So for example, if I were to give you a circle and I were to sketch in ST and I were to sketch in PR and they intersect at Q, and I tell you that PQ is 6, I tell you that QR is 4, I tell you that QT is 6 or 8, not 6, and SQ is X. And it's going to say find X and the length of PR and ST. Okay, so here to set this up, we take the length of PQ times the length of QR and set that equal to the length of QT times the length of SQ. So we know that PQ is 6, we know that QR is 4, we know that QT is 8, and we know that SQ is X. So we go ahead and multiply. We know 6 times 4 is 24. We divide both sides by 8, and we get 3 is equal to X. So therefore, the length of SQ is equal to 3. Now that we know that, well, we can already find the length of PR. PR is equal to 6 plus 4, which is 10. And now that we know what X is, it's 3, we can find the length of ST by doing 3 plus 8, which gives us 11. That's pretty straightforward. Okay. So, second theorem that we have is what's called secant-secant. So remember that secant-secant is, when we talk about a secant, we're talking about a line that passes through the circle in 2 points. So for example, if I give you this picture where we have two secants and they intersect at this point outside the circle. So we call this A, we call this B, C, D, E. So secant-secant theorem says that if I take the length of this entire secant AE, which is the whole, and I multiply it by the outside part, which is BE, that's equal to the whole times the outside of the other part. So it would be CE times DE. Pretty straightforward. And these two secants intersect at the common point. Okay. So, for example, if I give you a circle, and I give you these two secants. So we have R, P, Q, ST, and we tell you that RS is 4, we tell you that ST is 6, we tell you that RP is 5, and we tell you that PQ is X. And it's going to say find X and the length of PQ. Okay? So in order to do that, what we can do is, okay, well, these are two secants. They intersect outside the circle, so I can use secant secant. So we can say that RS times RT, so the whole times the outside, is equal to RQ, the whole, times the outside, RP. So we know that RT, the whole segment is 10. We know that RS is 4. That's equal to, we know that RQ is X plus 5 times RP, which is 5. So we solve this equation. So we multiply and distribute. So we end up with 40 equals 5X plus 25. We subtract 25 from both sides. We end up with 15 is equal to 5X. We divide both sides by 5, and we get 3 is equal to X. So therefore, X for PQ is equal to 3. Now we can find the length of, that should have been RQ. So to find the length of RQ, we do 5 plus 3, which gives us 8. So that's secant-secant product theorem. Okay. So the last theorem involving segments of a circle is what's called secant-tangent product theorem. So remember that a tangent is a line that is outside the circle and it intersects with the circle at one point only. So here's our secant, here's our tangent. So we have A, B, C. We're going to call this D. So this theorem says that if I take the whole of the secant times the outside of the secant, that's equal to the tangent squared. So this would be the whole AC times the outside BC, and that's equal to DC squared. So for example, if I sketch a circle, and I have my tangent line up here, I have my secant line, we'll call this PQ RS, so PQ RS. Okay. So then we know that PQ is X, we know that QR is 4, and we know that RS is 5. Okay. So PQ, this is our tangent, SQ, this is our secant. So we do the whole thing, so it's going to be SQ times RQ is equal to PQ squared. So we know that SQ, the whole thing, is 5 plus 4, so that's 9, times RQ, which is 4, and that's equal to X squared. So then we do 9 times 4, that gives us 36. We take the square root of both sides, and we get 6 is equal to X. So therefore, the positive here is 6. We could technically say negative, but remember distance isn't negative, so we wouldn't use that here. So that's the secant tangent product theorem. So this wraps up our unit on circles. As always, if you have any questions, feel free to email myself or Mr. Ard. Send us an email with your questions or send us an email requesting a Google Meet, and we'll do everything we can to get that set up with you. All right, so until next time, we will talk to you later. Have a great day.